Hi everyone. So today we're going to be working on fun with functions. This is our last lesson of the quarter. Um, well, there's day one. Today's day one. The next time will be day two. We're not finishing this lesson, but this will be the last lesson. Crazy, I know. So we're going to be making sense of different representations of a linear function. We are on page M223. So we're back in the book. This is our warm-up. So we had 3 points, no, 3 sets of points, I should say. And we were looking for the slope. Let's be pink today. And if you remember the slope is just, let me just write it over here. Slope is just the change of y. So how much the y is changing over the change of x, right? So how much did the y change and how much did the x change, right? And that's all that is. So we more formally say y2 minus y1 over x2 minus x1. And basically what that is we're just taking those two y coordinates and subtracting them, and then taking the two x coordinates and subtracting those. That's it. I know it looks super complicated stuff. All right, so if you look right here, I like to start with the 12 minus 10, right? Because 12 is bigger than 10, so I don't have to deal with negative numbers, right? That's my hack for you, right? So 12 minus 10, which is going to be 2, right? Technically, I could just do this in my head. And then 3 minus the 0. So if I'm going from the right point to the left point, then I need to continue that with the x coordinate as well. I can't just do whichever combination. That doesn't work, because then your numbers will be fine, just your negatives will be off. Yes, pretty sure. I didn't think that through. But yeah, the difference, you'll have the difference, but will have the wrong negatives. So 12 minus 10, which is 2, 3 minus 0, which is 3. So our slope here is 2/3, which basically means for every 2 I go up, I'm going 3 across. Okay, 2 up, 3 across. When I say across, I mean to the right. All right, and then same thing here. We're at a point -1 of 4 and 4.5 and 1 and -4.5. So some people in class said that was 0, but that can't be true because 4.5 for the y and -4.5 are two different things, right? They're actually, it's not the distance of 0, right? One's on the right hand side, one's up here and one's down here, because we're looking at the y-axis right there. So the y values. So again, I'm going to go from right to left, because so -4.5 minus a 4.5, which is going to be not 0. That's going to be -9, right? So that's what we have, that -9 there. And then 1 minus a -1, 1 minus a -1. And if we look, remember, minus and negative, that's the same thing as a plus. So 1 plus 1, which is 2. So our slope is -9 over 2. And what does that mean? For every 9 we go down, we're going 2 across. Okay, 2 across to the right. So 9 down, 2 to the right. That's what our slope is going to be. And every time we do that, it's like if you think about steps, right? If we go 9 inches down, we're going to go 2 across. That's not a very big step, but it's a very steep step, right? And it's very tiny. So maybe you could get your foot, like your toes on there. But yeah, it's going to be pretty steep though. And it is, and remember, it is going down because it is a negative. We're subtracting 9 every time, right? For every 2 that we go to the right. So, and then we look right here for number 3. Again, 12 minus 0, we have right there, and which is 12. And then 0 minus -1. Remember, if you're subtracting a -1, that's the same thing as adding 1. So it's just 12 over 1, or just 12. All right, so this one would be, so every time we add 12, we're going 1 to the right? Because if you remember, it's just over 1, right? So 12 up and 1 to the right, 12 up, 1 to the right. Alrighty, so again, this is probably your steepest one, 12. Let's take a look at here. Our learning targets for today is going to be to determine whether a scenario, equation, table, or graph represents a linear relationship. You look at one of these things, do you know, is it linear? We'll find out. And then next one is calculate the average rate of change from a table. And then, and we said, what is the average rate of change? That's exactly the same thing as a slope. Okay, it's just another way to look at it. Usually when we're looking at average rate of change, that's going to be looking at like scenarios, right? Story problems, real world situations. And then it says write, and we're going to write functions given a table of values. We'll do a little bit of that. And then the next time we meet, we're going to be doing the rest of these, right? And then we're going to have the review and then a test. What? Very crazy. I know. All right. So, well, are you or aren't you? So we're going to determine whether this model is a linear or nonlinear function, right? And if you notice, we highlighted, or I highlighted, all the ones that are linear, so you can kind of tell which ones are linear. But what I would do is I would try and figure those out first. Or if you don't know, then watch the video and then try doing it yourself later on. Try not to remember where all the linear ones are. But there we go. So scenario A says a tree grows 3.5 inches every year. So if you see that this is something that we keep on adding every single time, every single year, right? That's what we call rate of change. That is definitely linear. So that 3.5, that's our, like if you want to think about like a common difference, which is our slope, which is our average rate of change. There we go. And then if you look at this one right here, the strength of medication decreases by 50% each hour it is in this patient system. So if you think about it, what I like to do, because 50% is just, it seems a little abstract to me, so I use regular numbers. So I said, well, what if we start out with, whatever the dose is, which is like, let's say 100 milligrams, right? I say 100 because it's pretty easy to calculate from 100. And what's 50% of 100? 50. Well, what's 50% of 50? 25. And if you notice right here, right away, we're not going down like by the same amount. The first time we're going down by 50, the second time we're going down by 25, right? So this is definitely not linear. It's actually exponential. This is not linear. So we just wrote down not linear. That's why it's not highlighted. And if you see right here, the area of a square depends on its side length. So I remember the area of a rectangle is length times width, but we want the area of a square. So I'm like, oh yeah, it's just length squared or side squared or x squared, whatever it is. Whatever that side length is squared because we have two of them. We're multiplying them, right? So this, anytime we have an exponent of 2, we know we're not dealing with linear stuff. We're dealing with parabolas. Okay. And so the only one that was linear was scenario A. And if you look at A, B, and C, this kind of alludes to what we're talking about in scenario C, is that anything with an exponent, right, or where the x is not like a regular, like equation A, then it is not linear. So if you look at equation A, yep, no exponents here, and it's just a regular x, just like this. It is multiplying with a -9, which is fine. You can do that because remember, that's the slope. So equation A is linear. If you look at B, notice that the x is in the exponent, which means that's exponential, right? So yeah, definitely, if you can't be exponential and linear at the same time. So it is definitely not linear. And if you look at this one right here, this one looks a little bit different, kind of like the point slope form, but a little bit different. So this one is not going to be, oh no, it is. I mean, it is linear because there's no exponent there. It has an exponent of 1. It does have an exponent. The exponent is 1, but we don't normally write that down. So yes, this is also linear as well. If you look at table A, B, and C, notice we found the differences between each of those points. And for table, we started with table C for some reason. And if you look right here, yes, we're going down by 15 every time, which is good. Okay. And over here, we're going up by 1 every time. So if these are all the same, and if you're going in numerical order, like it's going up by 1s or up by 2s, it's going in even increments, then your Y difference has to be the same. If it's not the same, we're in trouble. Okay, so yes, so this works. If we were to ask for our slope, it would be like -15 over 1, right? So every 1 that we go to the right, we're going 15 down, right? Or if you want to think about the other way, every 15 we go down on the Y, we're adding 1 to the X. That's it. So every single time we do that. And then notice for B right here, 1, 1. So you're like, oh, we're just adding 0, right? So that's the same. So far so good. And if you look on the left-hand side for the X, yes, we're just adding 1 every single time. So is there a slope? Is it constant? Well, you're like, yeah, every time it's just 0. We're adding 0 every single time. And then each time for X, we're just adding 1. So actually our slope here is, if I want to call our slope, so 0 over 1, which is just 0. So basically we're saying that there is no change. right? Which makes sense. So every time we're adding nothing. So if x is 3, y is 1. X is 4, y is 1. X is 10, y is 1, right? Every time y is 1. Right? That's not changing. It's quite not fun, right? But yes, this totally works. It's not a very fun pattern, but it is a pattern nonetheless. So this one, that's why we highlighted that one. And table A, if you look at this one, here the y is going up by 1, so that's good. Right? 3, 4. But if you notice the x here, we're going up. We're not even going up. We're just saying 0. There's nothing, right? The problem with this one is that it is linear because there it's constant, right? But it's not a function, right? And we had talked about whether it's a linear or nonlinear function. They made that distinction. So this one is not a function. Linear, but not a function. If you take a look at we actually did plot them. So if x is 1, y is 3, x is 1, y is 4, x is 5, y is 1, or y is 5. Did I say that right? You know what I mean. And so notice right here, it makes it a straight vertical line down, which means it does not pass the vertical line test, which means that's not a function. And if you guys remember, for every input, there's only one output. So this input of 1, where x is equal to 1, we have 3 different outputs, right? Can't have that, not predictable. So therefore, this is not a function. So linear, but it's just not a function. And if you take a look at this one, A, B, and C, obviously A, not linear. It's not a straight line, right? So not a function, it is a function. It's just not linear. And B, we did highlight because, yep, straight line, it is decreasing, but that doesn't, it is still a line. And C is a line. However, it is not a function. So we did not highlight that one because just like how we did for table A, it's not a function. There we go. And then we're going on, we were finding slopes for this one. So if you read here in the previous activity, all the tables, they went up just by ones, right? So that's usually what we were doing in the arithmetic sequences. They always, because each term is term 1, term 2, term 3. There's no reason for us to go like skip terms, right? But not everything is arithmetic sequences, right? I know, crazy. And so what if we were skipping? So like for this one, for A, instead of just going by ones, we're going by 3s. So -2, 1, 4, 7, like, but we're going in, it is the same, right? And over here on the right-hand side, we notice that we are going down by 0.75. And if you don't remember, just subtract, right? Like how we do for common differences. And so 5.5 minus 4.75, that would give us 0.75. But we do know that it's a negative because we're going down, right? It's getting smaller. So we're subtracting 0.75 every single time. So the question is, what's the slope then? So we're going to go the change of y, which is negative 0.75, over 3, which is the change of x, right? And so when we divide that using your calculator, or you can think it in your brain, if you're like, okay, if I have 75 cents and I divide it with 3 people, how much does each person get? Oh, a quarter each, right? So we got -1/4 or -0.25. Either way is okay. And how do we get this +5? Well, we just kind of like reverse engineered it, right? Because we're like, well, if you know that every one step we go, when we go for x, we're going to actually decrease it by 0.25, right? 25 cents. So if we go the reverse way, so if I, then what would the previous number be? So then we'd have to add 25 cents to it. So it would actually be $4.75 plus 25 cents, which would be $5. I don't know why it went into dollars, but that's what it reminds me. So that's how we got this to be 5. It's reverse engineering. Okay, so here's B right here. We said this was, so we notice right here, we keep on going up by 8s, which is good. And if we notice here on the left-hand side, we go up by 2s, but then all of a sudden between 4 and 8, this is an 8, not a 6, which means we're going up by 4. So because of that, it is no longer linear. If we were to plot all these points, we would not be able to draw a straight line through it. Okay, you want proof? I give you proof. All right, so let's take a look here. Let's see if I can do this. Okay, here we go. So here we have 0, 5. Okay, that's the black point right there. And then we have 2, 13. Okay, I'm going to scroll this down a little bit so you guys can see it. And then we're going to go to 4, 421. Oh, yes, right there. Totally missed that. And then 8. So far it looks really good. It looks like nice straight line. And then 8, 29. Do you see how it like bends a little bit there? Like it's like it goes like this and goes cook. Can't have that. All right, so this is not linear. If we were to try and put a line through it, so our slope would be 8 divided by 2, which is 4. So y equals 4x, and our y-intercept is 5. Right, see here, where x is 0, y is 5, that's our y-intercept. And so do you see how it crosses all those 3 points, except for that one? See how it's not linear? Yeah, not linear. Piecewise function. All right, so that's not linear. And then now we're talking about Dylan. So Dylan sells pretzels at festivals on weekends. The table shown is a record of past sales. So obviously these are not going to be like in even increments like we do here. So then what do, right? And we tried. Well, we're like, well, let's try this out. And so we tried. Well, 37.5 divided by 15. Well, that's 2.5. And 105 divided by 42, well, that's also 2.5. And if you do these calculations, that totally works. You're like, well, that's not what we did before. So let's do that, right? So we're not going to try and find patterns here because there's no pattern in for the x, but we can find the difference here, right? So if you're like, okay, 105 minus 37.5. So we've got our thing right here. So we'll do it right here, number 6. So 105. Nope, not 106. 105 minus 40 minus 37.5. 7.5. Literally, you can just use any two numbers. You could have, honestly, we could have just used 145 minus 105. Let's do that instead, because this is a little bit like weird with the decimal. So let's go 145 minus 105, which I should already know is 40, but you know, since we were at it. So there's 40 right there. And then we have, let me just erase this guy. So this is 40. And then this right here is 58 minus 42, which is going to be 16, right? And so what is 40 divided by 16? We'll be like 40 divided by 16. And we have 2.5. We're like, what? Okay, it's just the same thing. All right. So I'm right on here. So that would be 40 divided by 16, right? You may have be wondering, well, would it have worked with these two guys? Because that looks kind of weird. How's that going to give me, because this should have been 2.5, right? So how's that going to give me what I want? Technically, let's write this over here. So 40 divided by 16, which is equal to 2.5. And so let's try this out. So we said that that was going to be right in there. So that was going to be 105 minus 37.5. Right, we got a 67.5. Right, so let's go with 67.5. And then these two guys, 42 minus 15. Let's go. So 42 minus 15. And we get 27. Right, and so this is going to be 27 right here. Is that 2.5? So let's try this out. So 67.5, divide that by 27, and we're going to see what that equals. So here we go, 67.5, divide that by 27. What? Yeah, that's going to be 2.5. All right, so we are good to go. And you could check that with other ones. I would check it a couple of different times just to make sure that you got the right one. But yeah, it looks like we got 2.5 right here. That's our slope. And then what's our y-intercept? Well, oh, I guess, what would, so then that means the slope means, let's see, is $2.50 per pretzel. And we don't get any initial income. So it's literally all we're doing is taking that 2.5 and multiplying it with the number of pretzels you sell or Dylan sells, right? And that's how we're going to get the amount. So how much would it be if you sold 75? Well, 75 times 250, right? And 75 times 250 would give you 187.50. Okay, so that's what that would be. Now the question is, that was lucky because we got that to be 0, but what if it's not 0? Then what do we do? This part right here. So this is the exact problem that Delaney had. Delaney and her friends went to the community fair, I'm thinking Washington State Fair, but cheaper. So they had to pay an entrance fee and then purchase 1 ticket for each ride. So Dakota is going to the fair tomorrow and wants to know the cost of each ride. Delaney and her friends help Delaney. Oh, Dakota, Delaney. I'm getting confused. So Delaney and her friends help Dakota by writing down how much money they spent and the number of tickets they purchased. So they've already went. I guess they were not being very nice friends because they didn't go with Dakota. Maybe Dakota wants to go with her family. I don't know. Anyway, so it says, so here's what happened. So somebody rode two rides, right? 1 ticket equals 1 ride, right? And so that was the $7.50 that they spent. Another person, 4 tickets, and it was $9. And remember that there is an admission fee, which means that you don't get any rides, you just get to come in, right? So that was the question. And don't look at the stuff on the right because we don't know that technically yet, right? And so this is what we did. So we looked at the differences here. So we know, so from 9 to 7.5, that was 1.5. 10.5 to 9 is 1.5. And notice right here, it is a much big difference as 3.75, right? And we're like, why is that? If you notice right here, everything they increase by 2, except when we get to the last one where from 6, it goes to 11, right? So since there's an increase in the X, there should be an increase in the Y, right? They should increase proportionally, like the same, like proportional amount, right? So let's take a look at here. So if we're looking for the slope, we can just, any one of these we could do. So 1.5 divided by 2 we can do, or we could go 3.75 divided by 5. Either way, we're going to get the same slope. So yeah, see how we put both of them there. And you can please check on your calculators to see if you get this number. So our slope is going to be 0.75. What in the world does that mean? That's going to mean it's going to be 75 cents, right? Because the Y, the amount of money spent for the number of tickets. So 75 cents per ticket. All right. So if we know that 75 cents per ticket, then so this person who went on 2 rides, well, they didn't spend $7.50 just for 2 tickets, right? So then we could figure out how much, and we're assuming not like the eating stuff, right? We can figure out how much they spent on the admissions ticket, right? So if we just go, if you kind of like reverse engineer it, so if there's 2 tickets, that would be 150, right? So 150 minus 750, that would be $6. So there's an algebraic way of doing this, but we won't get into it. But we're gonna just use our brain, which is still doing math, right? And so that would be $6. So that's how we knew that the admission fee is $6 and each ticket costs 75 cents. And so if Dakota has $20 to spend, ooh, she's rolling with the money. How many ride tickets can she buy? So again, so here's our formula right here. So Y is equal to 0.75 X plus 6. Because our admission fee, again, that's just a one-time fee. That's our initial fee. So that's going to be our plus 6, our Y-intercept. And then each ticket costs 75 cents. So that's the recurring cost, right? So depending on how many tickets she wants to buy, that's going to increase or decrease the amount that she's going to have to pay, right? So if we want that to be 20, here we go. We're just going to plug it into the Y because that's our Y is our total cost, right? See, this is our X, this is our Y, which is our total cost. Okay, and so how do we solve for this? Remember, we're going to subtract 6 on both sides because we got to get the X by itself, got to reverse engineer this. So if you think about it, it kind of makes sense because actually it very much makes sense because if you basically you take the 20 bucks, what are you going to do with it? You're going to take away the $6 because that's how much you know you're going to pay for admission. What do you have left? 14 bucks. Well, what are you going to use that 14 bucks on? So there's a 14 bucks equals to 0.75x. Well, let's see how many tickets you can buy. Well, how would we do that? We would divide it, right? So here, I'm going to just write this a little bit bigger because that's kind of small. So we're just going to divide it by 75 cents. So you take your calculator, which I forgot I'm using Desmos. I'll use Desmos. So we're going to take that $14 and we're going to divide that by 0.75. And it looks like You can buy 18.6 bar of them. Well, we can't buy that. That doesn't make any sense. So so what we're going to do is I'm going to just change this to fractions to help us out here. So, I don't like that. So it's 18 and 2/3 because 6 bar is 2/3. I'll just do that. So we have here 18 and 2/3. So how many tickets can we buy? Or can Dakota buy? Can't be 19 because we don't have enough money for that, but we can buy 18. So we can say she can buy 18 ride tickets. And with the 66 cents left over, she could buy something else. I don't know what's available for 66 cents, but yeah, whatever that is. All right, but that's how we know how many tickets she can buy, right? See you guys later. Have a good one.